This is part 2 of our lesson on rational exponents. So in this part, we're going to be doing an investigation to see what a rational exponent does. So the question that we have is, what does a rational exponent do? And I have 2 examples that we're going to take a look at. So the first one, I did 9 to the 1/2 times 9 to the 1/2. And what we're going to do is try to do this 2 different ways to see if we can figure out what 9 to the 1/2 actually equals. So I'm going to start by using exponent laws. So here we are multiplying 2 things together with the same base. So when we multiply 2 things together with the same base, we leave the base the same and add the exponents. So this would be 9 to the power of 1/2 plus 1/2. Now, 1/2 plus 1/2 would be 2 halves, or 1 whole. 2 divided by 2 is 1. So this is 9 to the power of 1. On the other side, I'm going to do something a little different. 9 to the 1/2 times 9 to the 1/2, I am multiplying that by itself. So another way I could write that is I could say that's the same thing as 9 to the power of 1/2 squared, right? I multiplied it by itself, right? So I could write it as 9 to the power of 1/2 squared. Now, we have exponent laws for multiplying exponents together. So I could say b to the x to the y is b to the x times y. And if I were to multiply this together, 2 times 1/2 actually equals 1. But I don't want to do that because we're trying to figure out what 9 to the 1/2 equals. So I am on this next line just going to write down again 9 to the 1/2 to the power of 2. So I know that 9 to the 1/2 to the power of 2 is the same thing as 9 to the power of 1. Now my goal is to try to figure out what 9 to the power of 1/2 equals. So I want to know what this is all by itself. So what I would like to do is figure out a way to get rid of a square. Now, is there a way to get rid of a square? How would I cancel out a square? The opposite operation of a square is a square root. So to cancel out that square, I would square root both sides, which means 9 to the power of 1/2 is the same thing as the square root of 9 to the power of 1. I know that seemed weird. We're going to go take a look at another example, right? But I did a little rearranging. I did some exponent laws to try to figure out that 9 to the power of 1/2 is the same thing as the square root of 9 to the power of 1. All right, there is one more example, and then we're going to look for a pattern. Here, I have 8 to the power of 1/3 times 8 to the power of 1/3 times 8 to the power of 1/3. So we're going to start this the same way we started it last time. We are going to try to use exponent laws. So these all have the same base. We said that when you multiply 2 things with the same base, you can add the exponents. So this is going to be 8 to the power of 1/3 plus 1/3 plus 1/3. Now, 8 to the power of 1/3 plus 1/3 plus 1/3. I'm going to, oops, got 3 on the brain there. That's going to be 8 to the power of 1 plus 1 plus 1 is 3 thirds. And 3 divided by 3 is just 1. So that is 8 to the power of 1. Okay. Other side, we're going to see if we can do something a little different with it. I have 8 to the power of 1/3 times 8 to the power of 1/3 times 8 to the power of 1/3. I have multiplied 8 to the power of 1/3 by itself 3 times. So I could say that this is 8 to the power of 1/3 to the power of 3. And if I check 1/3 times 3, so on my calculator, if I did 1 divided by 3 times 3, that does equal 1, right? So it would still work out to be 8 to the power of 1. But I don't want to do that. What I'm going to do instead is just copy this down for one more line. And then what I would like to do is see if I can find a way to figure out what just 8 to the power of 1/3 is. Which means I would like to find a way to get rid of that power of 3. Now, we haven't really done this before, but if the opposite of a square was a square root, the opposite of a power of 3 would be a third root, or sometimes called a cube root. So we write the number in the little check mark part that tells me that we're doing a third root. So that means that 8 to the power of 1/3, let's do that in red, equals the third root of 8 to the power of 1. So, what did having a fractional exponent do? So when we talk about rational exponents are exponents that are fractions. Well, when I had 9 to the power of 1/2, it made a square root of 9 to the 1. And when I had 8 to the power of 1/3, that gave me the cube root of 8 to the 1. Now the 1 that was on the top, this part here, showed up here in this example, and it showed up here in this example. What happened to the number on the bottom? Well, the number on the bottom, the 3, showed up in front of the root. What happened to the 2? I don't see a 2. Well, square roots are so popular, we don't usually write in the 2, but there is a secret 2 right here anytime you do a square root, meaning that this number here actually is the number that's the root. So when you have an exponent that's a fraction, the part on the top stays a regular exponent, right? The 1 stayed a regular exponent. And the part on the bottom in the denominator becomes a root. So the denominator of a rational exponent makes a root. Another word for a root is a radical, if you want. So I would probably write b to the power of x over y is the same thing as the 1 on the bottom makes a root. So that would be the y root, that doesn't roll off the tongue very well, of b to the power of x. Okay, so I will see you in the next video to try some examples.